This is problem number 12 on the sample test problems for test number 2. Find all solutions to the equation tan squared t minus 3 tan t equals 0 for 0 less than or equal to t less than or equal to 2 pi. Okay, easiest thing to do would be to graph that equation or graph the left-hand side on the calculator, find the x-intercepts just by using the 0 command on the calculator, and maybe we'll do that at the end just to confirm. But what we'd like to do is do this question without the graphing capabilities of our calculator. So let's do some algebra. It feels like we can factor out something from both of these terms here. So we're going to factor out a tangent of t. And then what's left, so it was tan squared, so we still have a tan t. And then minus, and then it used to be 3 tan of t, now it's just minus 3. So now we'll split this thing up. Either the tangent of t is equal to 0, that 0 on the right-hand side was really important, or the tangent of t minus 3 is equal to 0. I'm going to put parentheses here just to make it really clear that minus 3 is not part of the angle. T is the angle. Okay, the first equation, tan t is 0. Well, I'm hoping that we just kind of know, like the nice values of tangents. So in this case, maybe, look at the unit circle if you wish. You need the y divided by the x to be 0. Said another way, you need the y to be 0. But hopefully you find that the angles that give you 0 for tangent are 0 and pi, and then 2 pi. And of course, there are plenty more, but we're only looking in this interval. The other equation, we'll get the tangent by itself. Tangent of t is 3. And so what I'm looking for is the inverse tangent of 3. And here we want some points, some angles, so that the tangent of those angles is 3. I don't think that these are going to be nice angles in terms of being on the unit circle. I don't think you'll find any points on our unit circle where the y value is exactly triple the x value. I guess I should clarify. Of course, these points exist on the unit circle, but they aren't going to be labeled. We've only labeled a few of the nice angles. So inverse tangent of 3, we'll use the calculator to find that. And if we're going to use the calculator anyway, why didn't we just graph it? Well, I had said we were going to avoid using the graphing capability, but at some point we need to figure out what this angle is, and I think the calculator is the only way to do it. So we're going to do second tan of 3. And before I hit enter, in fact, before I hit sine, cosine, or tangent, any of those buttons, I need to make sure I'm in the right mode. What mode should we be in? We should be in radians because we're looking for answers between 0 and 2 pi. So radians is the right thing. I'm going to go ahead and change it to degrees just for a second to get the wrong thing. So 71.565 degrees is fine, but it is not in this interval. So if I change my mode back to radians, all I have to do is hit enter. It'll recalculate the same thing. That's the answer in radian mode. So 1.25 radians. But there's another answer out there. If you think about the geometry here, we've got our circle, and 1.25 radians is somewhere in the first quadrant. I know that because pi over 2 is around 1.5. And so 1.25 is a little less than that. And I know that there's another angle that has the same value of tangent because of the symmetry here. Like this has some x and some y. And if I were to just shoot to this opposite point over here, it's the negative x and it's the negative y. But when I take the tangent of the bigger angle, this angle going all the way around to there, well, it's going to be the y-coordinate over the x. And the y-coordinate we're calling negative y, and the x-coordinate we're calling negative x, but it's reduces to y over x. It's the same y over x up here. So it's our job to know that like every trig equation, almost every trig equation has two different answers between 0 and 2 pi. So 1.25 is one of the answers. It feels like we need to add something. I know that that's half of a revolution, which is pi radians. So the other answer is 1.25 plus pi. Calculator will never give you this other answer when you hit the inverse tangent button, it will only give you the one in the first quadrant or the fourth quadrant. So if we add pi to that answer, and we get about 4.39. So our complete list of all the solutions, let's see, we can, maybe we can list them in order. So 0 is the smallest, then we have 1.25, then we had pi, then 4.39, and finally 2 pi. And certainly you're welcome to check these on the calculator, so we'll go ahead and try that now. So we'll go into y equals, and we will type in the original equation way up at the top. So we want tan squared of t, so we're doing tangent of t, or x squared, minus 3 tangent x. And we'll think about the window. We're looking between 0 and 2 pi, so those are the x's. And then for the y values, well, negative 10 to 10 is okay. I mean, tangent is going to shoot off the screen. But really, you just need to make sure 0 is in between your y values. So let's go there, and if we wanted to change the window, we can. So we're looking for places where the graph is 0. That is where it hits the x-axis. So we've got 1 point, 2 points, 3 points, and then a fourth point over here. Oh yeah, and the fifth one is way back there at the origin. So I'm feeling pretty good about 0, and you could check a couple of the others. We'll just do this real quick. So let's use the 0 command, number 2. And all you have to do is type in a left bound. Let's focus on this number right here. The hash marks are at 1 and 2 and 3. So you can scroll left, but it's kind of annoying to scroll left until you get past this point. So I'm just going to type in 1, which is definitely less than left of this point right here. So we hit 1 and enter, and then a right bound. So you can hit 2. I'll try it. It might be a little risky, but let's see what happens. Guess doesn't matter, so we'll hit enter. And we get 1.249, which is this answer over here. I was a little bit concerned because if there's a vertical asymptote in here, and it's kind of hard to know because it's off the screen at the top, if you pick 2 and it's past the vertical asymptote, then it'll give you some error. But that one was okay. Let's try one more. We'll try to find this answer right here. Second calc, and then number 2 for 0. So I'm focusing on this number. It's definitely between 2 and 4. So I'll hit 2 as my left bound, 4 as my right bound, and then the guess doesn't matter, just hit enter, and we should get something very close to pi. And that's it right there.